Hi everyone, and thank you for joining. Let's continue with another textbook question, page 75, number 16. Let's read the question first. For the function f of x equals x absolute value of x, show that f prime of 0 exists, and then determine the value of it. As you can see, we are dealing with an absolute value function, and we're trying to find the derivative of it, and then evaluate it at x equals 0. Now, as you know, we do not have a ready-to-use formula to differentiate an absolute value function. For example, like we have with the power terms. So we say that the derivative of x to the power of n is nx to the power n minus 1. We don't have a magic formula like this for our absolute value function. So guess what? We're going to use the one and the only, the first principles formula here. So let's start by writing the first principles formula. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now remember that this expression inside the limit is simply the expression that represents the slope of the tangent drawn at any point on the graph of a function. And I'm trying to actually explain this again because it seems that we are still kind of mixing up the idea of a limit with a derivative and the slope of the tangent again. So remember that the derivative is equal to the slope of the tangent, and the slope of the tangent is found as the limit as h approaches 0 of the slope of the line that we draw between two very close to each other points. How close are they? H units horizontal distance, and we make that h unit distance equal to 0 in order for these 2 points to become a single point and for this line to become a tangent line instead of just a secant. So back to our derivative here, we are going to bring the function x, absolute value x, into the limit. So apply this function in it. So we have the limit as h approaches 0. So instead of f of x plus h, we are replacing x by x plus h, as you can see. Now we'll write, instead of x, x plus h. We want to keep this in brackets because it's a binomial, so the entire thing is multiplying the absolute value of x, which again will be replaced by x plus h here. And then minus f of x is simply x absolute value of x, and this will be divided by h. As you can see, we cannot directly substitute h by 0, not yet. We save that as our last step. But what we are going to substitute is the value where we are differentiating this function. So we are differentiating the function at 0. So what that means is we're finding the derivative at 0, so we will be replacing the value of x by 0, because that's what we are doing here, right? So here is 0 and here is 0 again. This will take no time, you'll see. So we have the limit as h approaches 0 of, I'm going to draw a big fraction line here, and we'll have 0 plus h in brackets times the absolute value of 0 plus h again. And then minus, again, we have x, which is 0, so 0 times the absolute value of 0 again. And the entire thing will be over h. Let's see how this simplifies. So we have the limit as h approaches 0, fraction line. Now, if you add a 0 and h together, that will make h. Inside the absolute value, you have 0 plus h, so that will make it absolute value of h. Here you have 0 times 0, which is 0, so there is nothing to subtract here. We can write minus 0, but that won't change anything. And that is divided by h. So look at this. So the limit as h approaches 0 of h, absolute value of h over h, will be the derivative at x equals 0. So do not mix up this value of x equals 0 with the h, right? So as you can see in here, we have a factor of h in the numerator and we have h in the denominator. These two will simplify each other. and we'll have the limit as h approaches 0 of absolute value of h. Now think about it. If we were to substitute h by 0 in here, would we be able to find the value of it? Well, the absolute value of 0 we already know is equal to 0. So therefore, we're going to say that, wait a second, what were we finding here? We were finding the derivative, and we measured the derivative at 0. So we're going to say that the derivative at 0, x equals 0, is equal to 0, which means that the derivative does exist. Why? Because we were able to evaluate it with no obstacles, right? So we easily simplify the h, and the value of the derivative is equal to 0. Now you're probably curious and you want to see what the graph of the function looks like, and you can always check your answers with Desmos. So let's write the equation. So we have y equals x multiplied by the absolute value of x. And let's take a look at the graph of this function. I'm just going to try to actually squeeze this a little bit so we can see it better. So as you can see, x absolute value of x is sort of a quadratic function. We are going to talk about how to build these graphs on a separate lesson. And as you can see, we have one arm of the parabola opening down on the left side, opening up on the right side. And as you can see, it makes an inflection point right here at 0, 0, which will make the slope of the tangent equal to 0. So I hope this made sense, and I hope that you found the instructions useful. And I'm trying to go back to my page. There you go. Bye for now. Thanks for watching.